Our presentation today features Ohio's Muskingum County bridge replacement with SPS deck on press brake formed steel tub girders. I'd like to give special thanks to Kay Jemison, Senior Vice President for SPS North America, a division of Intelligent Engineering, for her coordination of this presentation. We're pleased to welcome our presenters, Doug Davis, County Engineer in Ohio's Muskingum County, Rolando Moreau, Bridge Lead for Intelligent Engineering, and Dave Cox, Plant Manager for Maico Industries, Inc. Doug?
Good morning. How are you today? Or good afternoon, I guess it would be. I wanted to give a little bit of a brief introduction to before the slide presentation kicked off. Basically, just to understand, for all you folks out there listening, as to how this project came to be. I was at a conference for an SSBA, Steel Bridge Alliance, and witnessed a presentation by the Buchanan County, Iowa county engineer out there for a tub girder with a concrete deck. And speaking with the director and the panel from the SSBA, they wanted to know if there would be another reason to build another structure in the country with the press brake tub girder. I wanted to be a little bit different, and I thought about this idea. I happened to be sitting next to Kay Jemison and talked to her and said, how about us putting the SPS panel on top of the tub girder? We talked about that, kicked around some ideas, and from that, I was able to take the Buchanan County blueprints for that project to the Ohio DOT. Went to the Ohio DOT, explained to them, asked them about the accelerated bridge, and what monies they would have available for experimentation for new structures, what funding was there. They took about 3 or 4 months to get back to me, want us to submit an estimate, and from that estimate, then we were able to put together more of a composite, a concrete estimate, as you would say, a little more finite cost. They agreed to go with that. So that's how the project came to be. That's how we're able to take it to Muskingum County. I have U.S. Bridge, who was the contractor on the project. I have him here with me today and would like to have him speak just a few words so that you folks can get an understanding of what thought process they had in their mind to ask them, hey, would you mind bidding on this project? And prior to the bidding and construction, what ideas they would have in mind. So Rod Lemaster here with U.S. Bridge.
Thank you, Doug. U.S. Bridge is a family-owned steel fabricating and construction company that has been in business in this area for about 80 years. When this project came out to bid, Art Rogovan and I looked at it as an opportunity to be involved with an interesting new project that was coming to our home county featuring innovative steel materials. Our manufacturing shop is in neighboring Guernsey County, but of course Art has lived here all his life, and I built my home here 23 years ago. As prime bidder, we wanted to be involved with as much of the fabrication process as we could, but we didn't have the capabilities of manufacturing the tub girders. We initially thought that we could fabricate a lot of the bridge components, but after we made contact with Maico through the Short Span Steel Bridge Alliance and AZZ Galvanizing, we realized that it would be best that everything except the bridge rail should be fabricated at the same facility. Maico, of course, is located about 1,000 miles from Muskingum County, so sharing fabrication of important structural elements is not a very good idea. We chose to fabricate the bridge rail because it was a standard Ohio system that we custom build for concrete and steel bridges all over the state of Ohio. Doug?
Thanks, Rod. I appreciate your input on that. That's what I have as far as an introduction to give you a little bit about why the bridge came to Muskingum County, how I got involved in the structure. So with that being said, I'd like to turn it over to Rolando, Intelligent Engineering, and he can start his presentation. Rolando?
Thank you, Doug. So today I'm going to give you a brief overview of SPS bridge decks. Then I'm going to dive directly into the design aspects of the bridge. Quick background, SPS is comprised of 2 steel plates bonded to a solid elastomer core. This results in a very strong, lightweight, and stiff product. It's up to 70% lighter than that of concrete, while maintaining less than 2 inches in thickness. SPS was developed back in 1993 and has been deployed in over 30 countries, spanning over 450 projects. This slide contains an overview of a variety of applications for SPS, ranging from floors in buildings to bridge decks, terraces, offshore, and marine applications. So fundamentally, SPS is a replacement for a typical 8-inch thick reinforced concrete slab. As you can see in the top graphic, SPS spans between longitudinal girders. In this case, it is bolted and achieves full composite action. All standardized bridge details, ranging from asphalt, a variety of wearing surfaces, to other bridge details and barriers, can all be readily accommodated. SPS received an AASHTO Innovation Initiative Award based on our experience in the first application of SPS back in 2008 in Texas. Typically, SPS spans between 5 to 8 feet and are manufactured in lengths between 20 to 40 feet. This gives weight in the zone of 37 to 51 pounds per square foot. Of course, SPS can be customized for any particular application depending on the design criteria. This table contains a side-by-side comparison between concrete and SPS deck. As mentioned, it's up to 70% lighter than concrete, can be up to 2 inches thicker. It comes completely prefabricated in the shop with the appropriate coatings, bolt holes, and penetrations ready to be assembled on site. When properly designed, detailed, and maintained, SPS can achieve a 100-year design life. The elastomer core was developed in partnership with BASF, who have used this particular elastomer in service for over 60 years. Then in the lab, what they did is that they accelerated the deterioration of it and was seen that we can achieve a 100-year plus design life. Of course, with any steel product, it must be properly maintained and detailed. The weight and prefabrication can be leveraged to create large prefabricated modules which are fit for ABC type construction. They are delivered to site on trucks efficiently, can be erected using small equipment. It's completely weather independent and can be assembled using single trades and all steel construction. A variety of wearing surfaces can be readily accommodated, as well as steel curbs, drain inserts, expansion joints. Drainage in the longitudinal transverse directions can be accommodated, and of course a variety of corrosion protection systems consistent with steel designs can be accommodated. SPS has undergone extensive testing to characterize its performance over the last 20 years. In particular for bridge decks, the crash performance, fatigue, dynamic properties are all important for designers. We've found that through testing, SPS is able to achieve at least a TL4 performance level. The polyurethane as well as the bond to the steel plates were found to be fatigue insensitive, and any fatigue is governed by the parent plate and connection details, again typical to any steel bridge design. We've also done live load institute testing on the bridge deck and found that the dynamic impact properties are consistent with that as AASHTO. Of course, all load reports, assessments can be made available to you. This picture is a side-by-side comparison of an SPS deck and a concrete deck, where pendulum tests were conducted by the Texas Transportation Institute back in 2005 to evaluate the performance of SPS decks. What I'm going to show now is a video of a pendulum test that was conducted. In this case, the SPS deck remained undamaged, and it should be noted that the thickness was less than 2 inches. The plate, what you see in front here is a fascial plate. Compare this with concrete, where we can see rupturing of the concrete deck surface. So that's an overview of SPS deck. Now to dive directly into the project, as mentioned by Doug, this was part of an A demonstration grant, which was awarded back in 2016 for the replacement of this existing 38-foot span bridge with a press brick steel tub girder and SPS deck. Due to the low-lying area here, extensive corrosion occurred to the bottom flanges and at the abutments of the existing structure. This is a cross-section and isometric of the bridge. It consists of 4 tub girder modules with SPS deck bolted to it to form a 2-lane bridge 24 feet wide. The bridge length increased to 52.5 feet in length, and everything was all steel was fabricated from A709 grade 50. The tub girder was press brake from a 5/8 stick plate to form a 22-inch deep tub girder. So combining the exterior and interior modules, they were pre-attached in the shop as shown in the picture here. As well, this has immediate load carrying capacity as there's no concrete closure posts that are required between the modules. The overall depth of the superstructure was minimized by the efficient subgirder design and the thin SPS deck. 100-year design life was made using a spray metallization on the SPS deck panels, while all other superstructure components were hot dip galvanized. This is an assembly of the bridge in the shop with the top plate SPS deck removed. As you can see on the exterior girders, there are these stiffeners that are located here at every 6-foot center, which coincided with the location of the post. These may or may not be required depending on site-specific conditions. Each tub girder had 2 access hatches as shown in the bottom picture for ease of inspection. Additionally, there are drainage holes located along the bridge as well. This is the erection sequence, which comprised of combining 2 modules in the shop with the guardrails pre-attached, lifting beams already in place, and erect the 2 modules and assemble on site. Each module in this case weighs approximately 31 tons. Had this design been done in concrete, the modules would have been twice as heavy as that of the SPS module. The SPS deck, as well as the tub girder, were designed for HL93 loading. Due to the hydraulic constraints at this site, a 22-inch deep tub girder was specified using a 5/8 stick plate. This is a selection table that can be used to determine the thickness of plates based on the girder as well as girder span. Due to the light weight of the deck and overall system, no camber is required. So the 2 modules arrive on site and then are longitudinally connected. This detail shows that connection, where it is a bolted splice plate with a completion field well for the top face plates of the SPS. The bolts are located on 6 feet center, which is required for AASHTO for sealing requirements. A crossfall of 3/16 and 1 foot was also specified. It should be noted that this has composite action between deck and subgirder. A TL2 guardrail system, as per ODOT standard, was readily accommodated using an exterior bracket as shown in the pictures. Alternatively, a TL4 system, which is a deck-mounted option, can also be accommodated. Looking at the expansion joint, we combined 2 ODOT specifications consisting of a compression seal as well as a polymer modified asphalt joint here to create a seamless riding surface. At the base, a standardized detail for the bearing was specified. It should be noted that the tub girders were anchored using 1 1/4 inch rods. Therefore, combining the entire project, this is the final delivered module to site with SPS deck bolted to the press brake tub girders, the bearing plates, splice plate for the longitudinal connection, expansion joint, as well as the guardrail and lifting beams are all ready to go. We had excellent match fit and dimensional accuracy. This is the last slide here, which shows a video of the erection of the bridge. So as you can see right there, each module was placed in 10 minutes flat, erected completely from one side using a 250-ton crane. Now I'm going to pass it over to Dave Cox at Maico, who will discuss the fabrication aspects of the bridge. Thank you.
Hello, everybody out there in webinar land. My name is Dave Cox. I'm the plant manager at Maico Industries in Ellsworth, Kansas. Just wanted to say thank you to Rolando and Doug. They were both a pleasure to work with on this high-profile project, and special thanks to Kay from SPS for all of her efforts to coordinate this project. In correlation with U.S. Bridge, Maico Industries is also a family-owned company with the founder, Paul Mai, that originally started his legacy in the steel fabrication industry in the early 60s and still has businesses operational today with PKM Steel, MSS Transport, and Salina Steel Warehouse. So this first slide is just kind of our company logo, a large sign outside our facility. And then we have a number of certifications, AISC certified with steel building structures, simple bridge and highway metal components. Our overview picture of our facility is about 125,000 square foot located in north central Kansas on 20 acres. Our welders are AWS certified, CWB certified, and we're also certified in Clark County. The slide here is showing kind of the components for the bridge girders at the infancy stage here. We'll start with some A5 or A709 grade 50 tub material. This tub material is 5/8 thick, 101 inches wide, 52 feet 6 inches long. The burn table that we're cutting the tub girders on are 16 feet wide, 125 feet long water table. The 400 amp plasma with the arc riding capability. We use this for multiple projects, whether bridges or multi-sided poles. We can cut up to 120-inch wide material, and occasionally there are some mills out there that can go as wide as 140 inches for larger tub girder applications. The next slide here is our press brake. The pointers are referencing to the air table, which is designed to close down to a 1-inch opening, and then can also open up to an 18-inch opening. And that's where the cursor is located there, and that allows us to bend a variety of different thicknesses and dimensions. It's also pointing to the inspection hatches. These are the interior cutouts that we do that were just pictured that Rolando shared as future inspection of the bridge. Allows that to happen. And we can offer press forming of lengths up to 60 feet on this particular machine without splices, and also unlimited lengths with design splices. So keep in mind this process is cold forming without the use of heat. The slide here is just a good overview picture from our burn table to the press brake. It's a 60-foot, 2,000-ton press brake. It's currently, in this picture, is forming a tub girder on our press, which is actually two 30-foot press brakes put in line so they can operate one press independent of the other or both in tandem. I should note this press is one of the largest press brakes in the United States. And up above you can see we've got a couple of 27.5-ton overhead hoist, and not pictured I've got 40-ton hoist and some other smaller hoist as well. So very capable of handling these large components. This picture here is just an additional picture of the press brake from the slave end, and you can see it's during the forming process of one of the tub girders, which, by the way, the bends that you see pictured are roughly 76 degrees, and we utilize a 2.5-inch radius punch to achieve those types of bends with this material. This picture is actually from the master end of the press brake. It is a close-up view of the tub girder as it's prior to being extracted from the press table end. And I did put in a couple pointers there to reference to the 5-foot deep throat opening on this press brake, which allows us to do large material forming. This picture here, you can see the width is mentioned there at 5 foot 10.5. These are just finished tub girders that came off the press prior to being transported or relocated over to the fabrication area. And each tub girder at this point is roughly about 11,200 pounds. This picture here is a good picture of fabrication in process. We have these intermediate bit stiffeners, diaphragms, and they're bolted every 6 feet. So there's a fair amount of welding fabrication going on prior to this diaphragm being bolted inside the interior tub girder. And then you can also see at the end here we've got some end caps that are welded on to seal off the end of the tub girders. This picture here is once the tub girders are fabricated complete, they're loaded onto trailers to be transported to the galvanizing facility, along with some miscellaneous pieces in the tubs above, which are primarily the intermediate stiffeners that are bolted inside the tub girder. This is an overview picture of AZZ Galvanizing. They were great to work with. They worked with us on both galvanizing and metallizing, as we'll see. But this is an overview picture of their facility down in Tulsa, Oklahoma, where these girders were sent for galvanizing. This is a good picture of one of the tub girders that's in process, that's just coming out of the galvanizing tank. And I should mention this is a hot dip galvanizing process, whereas the materials that are going through a series of vats called the pickling process. And the parent material, in this case the tub girders, are going to be immersed in cleaning solutions, acid, rinse tanks, flux tanks, prior to being fully immersed in the zinc kettle, which the molten zinc from this kettle is approximately 850 degrees. The size of the kettle there in Tulsa to allow this thing to be fully immersed is 5 foot 3 inches deep, 7 feet wide, and 56 feet long. So depending on the material thickness here involved in hot dip galvanizing to get the cathodic protection, you know, these pieces will stay fully immersed for a certain period of time, whether it be a minute, couple minutes, just depends on a couple of variables. This picture here is kind of a busy picture. It shows, you know, our steel fab shop area with our highly trained certified welders operating brooms and wetbacks and leaf blowers. So that's not something common to our industry, but in this case, for these types of decks, it's very critical for the interior of these decks to be clean after the SP6 blasting surface profiling is complete. The polyurethane core materials that will be ejected within the deck cavities later within this process will have to have good adhesion. So the interior surface plates of those decks have to be really clean. And also in the picture here, you can kind of note various clamping devices that we use on the ridge frame, on the outer frame bar, to ensure that, you know, any gaps are very minimal. And the bottom plate, I should mention, is 5/16 thick. The frame rail here is 1 1/8 inches thick, and then we, of course, will cap that off with another 5/16 thick plate. The next photo here is one of the deck with the cap plate on now, and our welders are busy welding. We utilize the gas metal arc welding to seal weld these deck panels, and in this case, we utilized 1/16 diameter metal core wire to complete the nearly about 130 linear feet of fillet welds needed to seal each one of these decks prior to the injection process. And I should mention this is like an E70 C series wire electrode certified to both AWS and CWB standards. The photo here is extremely busy once again, so I'll kind of start from the bottom. We have a restraint, what we call a restraint table, and that's actually built with a slight angle on this table, which ensures this material to flow upwards and push the air out of this cavity here, which is an overflow funnel. The restraint table is built with that slight angle, approximately 50,000 pounds of weight on top of this table to ensure the flatness during the injection process. The polyurethane core materials generate an immense amount of heat during the injection process and curing process also, and will subsequently expand. So the purpose of the table is to keep the deck panels from expanding during this process. And you can note by the pointer there, as I mentioned earlier, the overflow tunnel. The injection process is being executed from the lower end of this deck table here, around where the cursor's at, and at the right hand end of the photo. And then you can see the multiple hoses pictured are carrying the components that are mixing at the injection gun, filling at the end of the deck. And the wood sheets, I should mention, are on both sides of the deck panels, and those basically, they serve a couple purposes. They insulate the deck panel during the injection process, and they also kind of absorb any flatness irregularities from the plate surface itself. This slide just represents the injection material, or the injection equipment, pumps, hoses, guns, and the product. This slide here is representative of a deck that has been injected, has came off of the restraint table, and now you can see by the pointer where there was a opening for the injection to occur. That has been plug welded, and down here at the opposite end of these panels you can see one of the welders finishing up plugging one of the holes that we just seen pictured with the funnel. This slide here is the mobile metallizing, of the injected deck panel. So once the deck panels are injected, we removed them, transported them outside, and AZZ had some personnel on site to do the metallizing at our facility, and these guys were really professionals, did a great job. They initially had to surface blast the material prior to metallizing, which is an alternative to hot jet galvanizing. Since this panel could not be submerged in molten zinc after the polyurethane core was injected, it had, in order to receive the cathodic protection, the next best thing was metallizing. So they came to our shop and performed that function. The next slide just shows after the metallizing is complete, we move the panels back into our shop. So the next step that will occur here is the CNC drilling and counter boring of the deck holes. And I should mention the deck holes themselves. Some may ask, why weren't they drilled before? Well, during the injection process, there's always that possibility of seepage and flatness being an issue. So we chose to, or it was specified really, to not to drill the holes until after the injection process had been completed. This photo shows it's, once again, a very busy photo. There's a lot of things going on here. We've got illustrating the fit up of the mock-up and assembly, preliminary assembly of the tub girders with decking prior to the match hole drilling. You can see some of the splice plates off to the right-hand side. They may look like they're guardrail posts, but they're actually, these particular splice plates will bolt the second segment of tub girders to this segment in its final destination or location. Off to the left side of this, you can see the guardrail brackets that we put on. And we also fabricated some custom beams, as I mentioned before, flatness, and then we certainly didn't want to disturb the coating's integrity by mishandling these with chains or clamps, so we fabricated some custom bars that would bolt to the upper portion of this deck. And then down below here you can see a couple of holes that we've identified. These are for drainage of the tub girders should there ever be a need to remove the bolts from the end of these tub girders in the field to allow for drainage, and then the bolts can be reinserted. And then down below you can see the bearing plates. You'll see in the videos coming up with Doug's presentation where these are critical to bolting to the concrete abutments. The next photo here shows, once again, just various things in process. We can see this long bar that has not been galvanized yet. There's a couple reasons why we did not do that, but primarily this bar, not only is it drilled, but it also the bolts go through these holes in the bar that bolt into the end of these tub girders, which we subsequently threaded as well. and then you can see some of the end diaphragms and the bearing plates as well. This slide here just shows more of the drilling and counter boring of the step deck panels, you know, as they're staged on the tub girders. And this is just an additional picture, once again, with some more of the deck panels that are put on. There's a lot of match drilling that's being done through the deck panels into the tub girders and counter boring of the tub and deck girder holes. This here is a good picture, a good summary of the amount of drilling, counter boring, holes. And I should mention too that all these holes that are counterbored with the bolts that are assembled also have a plastic sleeve that is inserted for various reasons. The next slide here is basically the finished product as it's being loaded out for shipment to the U.S. bridge, where they're going to be doing their guardrail installation and final prep and inspections before transporting those tub girders onto the job site. And I should say the U.S. bridge was really a phenomenal partner to work with throughout this entire process as well. We appreciated that. And here we can see load number 2, which weighs just a tad bit more than load number 1, primarily because of the extension gussets there that will help splice to the other tub girder. And I should also mention here too that the MSS Trucking was a great partner in this. They delivered both bridges without any issues and did an excellent job shipping these components to the job site. So I believe that completes my part of the presentation.
Hello, this is Doug. I'm going to give you a little insight to the project. I'm going to flip through some slides rather quickly, but I think they're very, very important to the project. That's why we kind of left them in here. You're going to ask maybe, why does this have to do with ABC? Well, I'll tell you, the reason that it has to do with ABC is because it can show the preparation and the work that the contractor did, U.S. Bridge, show how neatly, how quickly, how they handled all the stormwater, how they handled the different sites of the structure. For those of you that have never torn apart a bridge or built a bridge before, I guess some of this, you'll be able to see the insights of it. While I'm flipping through these slides very briefly, I'm going to have Rod LeMaster speak again and talk a little bit about what happened here on the job site.
The existing bridge was pulled out. We had a little bit of flood water at times. The backup of the water really created a lot of mud, a lot of issues with the thing. And then there was a 30-day bridge closure. It was a real important issue with the contract. So we cast all of the abutment concrete prior to the delivery of the bridge. The abutment wing wall design only allowed 1 inch of clearance, and we were concerned that there would be too little room to swing the bridge into final sections into place, and because there was some underlapping plates, and we wanted to get it underlap the plates plus fit over the anchor bolts. So to ensure this fit up, we actually set the bridge on top of the bearings box, and once we got the bridge sections bolted together, you know, we used a jacking system with a manifold system that actually lowered all of the sections at the same time right down on top of the anchor bolts. Of course, the crane we had for setting this thing was a 250-ton hydraulic crane. We set everything from one side, one spot. There's a go ahead, Doug.
Okay. Well, thanks, Rod, for giving that insight. We're going to get into this, and as you flip through these slides again in the future, you'll notice that the day of the week is on there, the date, I'm sorry, and also the day of the construction. Granted, this was a 30-day limited closure, and they completed this project in 26 days. So here we are now, looking at the tub, getting ready to set. We saw the video from Rolando setting the structure, but one of the things I want to picture out in this slide here is looking at the end of the tub. See the bolts in the end of the tub itself and the diaphragm. The reason that those were there, those holes had to be drilled there so that when the tub went to the galvanizer, when they picked that heavy tub up out of the galvanizing with the parts we wanted to make sure that we had all the galvanizer could flow out of that for the fluids. So that's the reason there's a bolt and a plug in the end of that tub, if you want to know why. Initially, some people may think that this is the bearing pad. This is actually not the bearing pad. We'll show it here in a little bit, but that is actually anchored to the bottom of the tub, so we can actually anchor this tub or bolt this tub down to the abutments for flotation. This picture shows the guardrail assembly put on the structure, the tube, as much as we could for fit up, help expedite work in the project, in the field, I should say. So here we are. We've seen the video. We're getting ready to pull the tub in the two sections off of the truck in order to be able to set that, or off the trailer to be able to set it. Swung those into place seamlessly. Everything went well. In this photo here, you can reference a little bit about what Rod LeMaster was talking about. We have our bearing pad connected to our plate, and here is the guardrail blocks that we used. We actually set the tub in two different sections, of course. Well, not everything of that massive weight is going to go together just exactly right. So what we're able to do is set those on those, be able to shim those just a little bit, get the tubs to match together in the field, do the bolting of it, and then they use the diaphragm system in order to lift the structure in one piece, pull out the wood blocks, and set that directly down on the bolts that you can see right here in order to actually bolt the structure down. Now, this is a pretty good picture of the stream here. This stream, why did we pick this particular location for this tub? 100% of this bridge is galvanized. The spray metallizing of the deck, the galvanizing of the tub, because this stream here has very much very high acid mine runoff, very low pH of the stream, and for that reason, we wanted to be able to protect it for the future. This location is quite a ways away from my shop in our county. Unless I specifically want to drive there, I don't normally just drive through this particular location. There's another really good picture, a still picture of setting the second section down. Here we're putting it together, and the anchor bolts are going in the very first day. So you look at day 16 was when we were setting the structure and bolting it together. Day 17, the structure is already together, set down in its final location. So in 1 day or 1 day and a half, they have this machine. This has been delivered. It's bolted together, set in place, and ready to continue with construction. This picture here basically shows, and you say, well, Doug, why are we showing concrete? This is an approach slab, but we have to figure out with the tub how to marry the tub girder with the SPS deck to the existing abutments and have smooth transition on the roadway. So this detail over here basically shows a sunken approach slab. It will have asphalt on top of it, you'll see later. But this also shows you the expansion joint. How do we account for the expansion? So this plate right here that you see, you will see it again. It's going to be a little dirtier than this picture here. It's going to be covered with some asphalt. But that's what we were doing in this picture, showing that we have a sunken approach slab so we can have that termination from the abutment here of the structure to, or the abutment here of the structure to the approach slabs. This picture here just basically showing that we're getting ready for roadway. And this is kind of my call. One of the things that I was concerned about, and not that I didn't trust anybody, but I'm kind of sticking my neck out with this project. If it fails, it sure makes me look bad in the county. Not that I ever thought it would, but having this deck being galvanized, or metallized, I should say, I wanted to make sure that we had a very good bond between the asphalt surface and the metal deck itself. So what they're doing here is applying a primer. All right, we've got a sheet type 3 rubber membrane that is on top of this, and it'll become pretty evident here in the future slides here why I particularly wanted to go that route. This is the end of the roll. This is our membrane or waterproofing, and again shows your expansion joint, also shows your typical abutment detail for those of you that need that. We're starting the asphalt process. They put this in 2 lifts. We had a base and a top, so we're going to go ahead and add our base. Then we're going to go ahead and we're going to skip the sunken approach slab. We're going to move to the other side. But look at the dirt, the dust that we're getting right now on top of this slab. If I was just afraid that we had any minute details of all, I wanted to make sure we didn't have anything that was going to break the bond between the asphalt surface and the metal deck itself. By putting in this roll here, the contractor was able to get from one side of the bridge to the other to continue with his asphalt process without stopping the trucks, going to the, driving 11 miles around to the other side of the structure, and then and having this little bit of minute dirt that we have on the deck itself right now is minuscule. Having this product here, once the asphalt is down, it will meld, and this will not be an issue. And being so, we're able to have a better riding surface by having the contractor come in, put the surface on the approaches, on the approach slabs itself, and go ahead and get the intermediate on the deck. Now, granted, this tub does not have any camber into it. It is completely flat. We also do not have any crown in the deck itself, in the SPS panel that is on top. It is extremely flat. So we have to put a crown in the roadway and the asphalt in order to shed the water. We did not want to have any ponding in this. So here's an inspector actually looking at the crown in the roadway, just verifying what was being done before the asphalt is actually rolled hard. Here's a finished product of the asphalt. We're down here on day 23. We've got a few things to button up for this project. Just showing some more approaches. And we've got guardrail to put in. So guardrail's going in on day 25. This is a picture showing both ends of the guardrail. So there's absolutely shows that having the tub girder or any other type structure, having the tub is not something specific that we have to change for the guardrail. It's no different with a transition than it shows with any other transition of any other bridge that we would assemble. Now, I talked about a plate a little bit ago that was going to be a lot dirtier, and here it is. So what we had to do specifically because of the tub, and this is the expansion joint, but because having the tub, we were not able to use a heat lance in order to remove this asphalt. If we did that, we might disturb the integrity of the SPS panel because of the urethane between the two pieces of steel. So what we did here was we went ahead and saw cut it. It came out relatively easy. Again, they just asphalted the day before it finished it. And this is the specification on the modified asphalt joint that we put in here to put over top of the sliding plate for the expansion. We've got a couple slides here that just shows the fit up, clean up of the project. And again, you've seen this slide before. This actually shows the detail, how big it is, and what the hatch is if we need to get up in here to do some inspections. We think there's a problem there. Don't anticipate it. We have that steel. It's completely galvanized both sides. If we're going to have a problem, I think we would have it on the outside. But also, one of the things that I thought was very specific of why I wanted to include this slide in my presentation. We talked about Muskingum County being very volatile. We have acid mine runoff in our county. We have a lot of good coal, had a lot of good coal mining over the period of years, but it left us the byproduct. It left us with the pH of some of our streams being very, very low. But not only that, we have very rapid streams. This stream is going to rise very quickly and go down very quickly. Some of the issues that we have with our existing structures is the fact that we may get a large root ball come down the stream that's maybe 3,000 to 4,000 pounds. And if this was a concrete structure, it beats the heck out of the side of that fascia. If this is a steel beam, okay, it could actually come here and all of a sudden, due to suction, it'll suck that piece of wood right up underneath there, or that root ball, and it'll get stuck between the beams, and it sits there and it beats the heck out of our structures. Having this tub structure here with this nice flat panel, there's very little void between the two panels. Once it's underneath here, it's going to disappear and it's going to show up downstream to be somebody else's problem rather than me. But this is a really good idea of why we wanted the tub. This bridge will be inundated at some point in time. There's a 10-year design life for this structure. The roadway will flood before the bridge actually does. So there's nothing in designing anything greater than the 10-year storm event. But having the design here, meeting the needs that we need for the 10-year design storm, having the flexibility of being more versatile and lasting 100 years is the reason that we chose this particular type of structure in this particular location. And that's what made it exciting for us in Muskingum County to be incorporated. And I thank the federal people and the Ohio DOT people for trusting me, Muskingum County, with the burden of being able to do a project like this in our county. Another couple pictures of just the finished product, day 26. And guess what? Here's what it looks like today. Maybe not today. It's a little overcast in Muskingum County, but this is what it looked like a few days ago. The grass is coming in. You can see the acid mine runoff in the stream, very prominent in this picture. But such a beautiful job. everyone's going to be on their cell phone and drive across and never realize that they just went across one of the bridges that's one of the first ones in the country of this type. And that's kind of what we want, I think, from being an engineer standpoint. That concludes my, I've got one more slide, excuse me. I do have a lessons learned slide that we can talk about, and I can leave this up if Mary Lou, if you would like for me to do that. But some of the things that we came about with these here is we realize that the substructure is going to be the same, no matter whether you're this bridge or another bridge. It's not something we have to design. It's not something we have to change. It's pretty much going to be the same substructure. So nothing there is going to be out of the ordinary or special. The locals truly appreciated this. We had fire and EMS that said, listen, if we can design structures like this in a 30-day lifespan, and to talk about the ABC of the tub girder itself, when you go back through the slides and you look, this was a 30-day closure. We did it in 26 days, or the contractor did it in 26 days. But you think about just the ABC of the superstructure itself. If we had good abutments to set this on, we could have opened this and closed this in probably less than a week, maybe 8 days. So if you go back and look at those dates, fire and EMS sees this as being something that is just out of the ordinary and something that we probably should expect for each one of these projects, especially rural America like we have here in Muskingum County, because we don't have the ability of having near roads to run around. 11 miles to run around a detour in this particular location could mean the difference between life and death. The risk management was much better considering the tight time frame for the closure of the roadway. The prefabrication allows for more of a controlled work and better construction. We had to get creative with that expansion joint. We had to marry two different ODOT standards together and get their permission to say, hey, is this going to work? This is federal money being spent inside the state of Ohio, being governed by the state of Ohio for us to use on our local roads. And they were great to work with. So if there's any DOT people out there from Ohio, but also the federal people, I thank you for this opportunity and working with us on this. We went with the hot dip galvanized SPS panels. They had to be metallized because we couldn't hot dip them, but AZZ did the galvanizing for the tub. This is a 100-year structure. Even with the pH of the streams so acid as they are, we're not going to have an issue out here in Muskingum County with this structure. We mentioned earlier in Rolando's talk about the internal stiffness of the stiffeners added inside the tub. We think that possibly that could help save time, fabrication, and also money on future projects that would necessarily need to be needed. And then one of the things I want to talk about, because we do have the metal deck on there, it's going to be impossible to lay the asphalt in one day. The SPS panel is such a great insulator that when you lay the intermediate course on the deck, you have to allow it for time to cool, and it had to cool overnight so we could come in and put the surface on the next day. The timing of this project is crucial. With the 30-day closure requirement, the weather could be influential, and the progress of could be influential in the progress and the critical path of the project. Coordination, as Dave mentioned, U.S. Bridge mentioned, Rolando with his intelligent engineering, SPS, and myself. Coordination was very critical. There's many hours to go into this being a one-off structure, and truly want to look forward to building more of these in the future. Rod, you had a couple words that you wanted to say here before we finished up?
Yeah, Doug, I'd like to point out that we instructed Maico originally to ship the bridge to us, to our plant, so that we could add as much of the rail as possible to save time in the field. And while at the facility, we rigged the sections to make sure that we had all of the necessary rigging, and we pre-fit the components together just to make sure there wouldn't be any surprises once we got to the job site. Then we additionally shipped the components to a storage area, since the bridge is actually about 40 miles from our plant, and we shipped them to a storage area near the bridge the day before so that we wouldn't have to deal with any traffic issues on the interstate and things like that. So beyond that, everything came out very well.
And I think I wanted to mention the fabrication on this particular structure took about 3 months. So you think about we're working at 3 months ahead of time in order to get everything together. Was there a few hiccups? Might have been a few hiccups here and there, but we're able to work together as a great team, a great group. Very pleased to how this turned out in Muskingum County. And that concludes my presentation, unless you have questions. So I head back to group.
Thank you, Doug, Rod, Rolando, and Dave. very interesting, informative presentation. Ben Bierman will now moderate the Q&A session. Ben?
Thanks, Mary Lou. Great job, guys. So, folks, we have all kinds of great questions. I got them grouped in different categories. We'll start with, we have the ones in design, fabrication, construction, and service performance and cost. So go ahead and start with the ones in the design category and trying to keep this technical as much as possible. So, Rolando, you had mentioned the plate widths and sizes that come with the SPS deck. What are the limitations in terms of the SPS deck itself? And I'll ask a similar question: is what are the limitations on how long can you go with the press brake tub?
Yeah, Ben, thanks for those questions. The SPS itself can be fabricated to the widths that are required for the design. I gave 5 to 8 feet as being the typical range, but we can tailor it to whatever specific bridge that you have there. In terms of the length itself for press braking, that's governed by the actual equipment itself, as Dave mentioned, up to 60 feet. But it's possible that you can add a third tandem or second tandem, depending, and achieve greater lengths. So really, the greater lengths and widths are possible. All depends on the project.
Great. Sticking with the SPS, have sidewalks been used on SPS deck panels? And if so, do you have connection or detail examples on your website?
Sorry, Ben, I missed the first part.
Sidewalks. Have sidewalks been used with an SPS deck panel?
Yes, we have done many sidewalks, and we can provide a list of examples for you in the final Q&A. And I can
Okay.
It's also available on our website as well.
Good. Can the deck, the SPS deck, be overlaid with concrete or a cast-in-place deck? And Doug, we'll let you answer that one. How about that?
There shouldn't be a problem with overlaying, but I wouldn't know why you would. If you did, you would probably have to manufacture the SPS panel prior to injection to have some kind of a shear stud on top of that, so that then you could apply maybe a thin lift white top layer of composite concrete or something with that. So yes, it could have a concrete deck on it.
Okay. And if you needed to, if you decided for whatever reason to get rid of your asphalt, you could put, I guess, maybe shoot shear studs in the SPS deck and put that single lift concrete on top of that, I suppose. Yeah,
that would just be the wearing surface that you're looking for. Personally, I do both on some of my other structures, but in this situation here, normally we put our concrete decks on our structures just because the asphalt is porous and it'll go through the deck and then onto the beams. In this situation here, you're not going to have that because the SPS panel is going to be impervious. All your seams are sealed, and we've got the Type 3 waterproofing on it. So I wouldn't see the lifespan of this asphalt deck traditionally in Muskingum County is going to last me anywhere from 12 to 14 years. At that point in time, I probably would come through and shoot an oil surface on it and do a chip seal overlay as an interlayer, and then again it would handle another 8 or 9 years. So we're looking at a 20-year life before you'd have to do anything. Now keep in mind that having this tub girder with the SPS panel on it, and if I give credit to Carl Barth for him having the testing for the tub girder, but they've never got the tub girder to fail. So in this situation, you could overlay and overlay and overlay this and make the asphalt thicker and thicker and never have to remove it. It's not where you have a height requirement. The only thing you would have to do is move possibly the height of the rail, replace that if you had too much of an overlay on it. But honestly, I wouldn't see why I'd put a concrete surface on top of this bridge ever.
Okay, great. So, Rolando, question for you. Can or have the SPS deck panels been attached to a concrete beam?
Not as yet, Ben. That's the short answer. We have done it for terraces in stadiums where we have attached it to concrete rakers. So that has been done, but not yet on the panel, the SPS.
Okay. And I guess if you were to pursue something like that, you would just put embedments in the concrete beam so you can attach the deck, correct?
Yeah, it could be done. We haven't done it today, but we can look at it.
Okay. Well, I want to move on over to the fabrication related questions. So, Dave, a lot of these would be in your category here. So, if you can, move on over to slide 27, if you don't mind, so we can get a visual. And as you're moving towards, I'll ask the question: was there an attempt to maximize the cut plate width from the 16-foot wide stock plate? And I guess this is sort of also design related as well. And this is related to the fabrication of the tubs, I believe. Ohio State, oh brother.
You want me to flip back? I apologize. What slide do you want me to have?
It was slide 27.
Okay, I'll get to that. I apologize. Slide 27.
There you go. Okay. So I'll repeat the question. Was there an attempt to maximize cut plate widths from the 16-foot wide stock plate?
Typically, on these tub girders, from what I've been told, is plates from the mill sometimes will have a bit of a sweep in them. And you always have to buy your plates a little bit wider and cut them square so that you'll have, when you start making the breaking the tubs, you won't have any oddball dimensions like that would be caused by a sweep.
Okay. And then there was you had mentioned that you used a plug weld when you sealed up the SPS deck after the urethane was poured in the panels. Did the plug weld damage the urethane? I want to say elastomer, but the correct word is urethane. Yeah, there you go.
No, Ben, that's a standard process that we have done, and it's fine. It's just a seal weld there, so it's low heat.
Okay. So low heat.
Yeah.
Okay, and if it did, it would be in such a localized area.
Yeah, correct.
Okay, and then there was a question about the galvanizing. Why not galvanize the top and bottom plate of the SPS deck before fabricating the plate?
It would cause a lot of damage when you were welding all of that, the perimeters of all those plates. You would lose so much of the galvanizing would burn back. So you're better off to, once the panel is fabricated, just metalize the entire section so you have one uniform coating.
And this picture shows it right there. I mean, there's the bead weld, or the weld that's going, the perimeter weld that's going around the SPS deck.
Yeah,
and I would add that the cathodic protection is going to be significantly compromised in the heat affected zone of the welding. So there'd be a tremendous amount of repair that would have to be done afterwards. And I should also note that the galvanized coating itself would not be very susceptible to adhesion of this polyurethane core afterwards. So it's much, the adhesion is much better being directly adhered to the parent material without any coating on it from the interior side of the deck perspective.
Okay.
Ben, I would just like to add just a slight comment as well. We also look at the heat that goes into the galvanization, and as well as the flatness of the plate. So that's just something that will have to be considered as well.
Okay.
The flatness. Yeah.
Okay. So we really get a lot of questions regarding construction. You mentioned that there was field bolting that was done between the two units when they were assembled. Was that all done and I believe you said it in the presentation, was that done all in one day, or the same day that the units were placed?
Same day the units were placed.
Same day the units were placed, the bolting was all done. The seam weld, there was a 52.5-foot seam weld that had to be right down through the middle of that deck center line. That took a little bit longer. That was into the next day, I believe. So the bolting, of course, was really fast and simple, but the seam welding took a little bit extra time. So that's why it went into the second day.
And because on the construction, you know, we're talking about ABC being accelerated to set the structure, but we're also talking about ABC accelerating the project in itself. You see, we still have some approach work to do on each side. The contractor poured both approach slabs in the same day, the rear abutment and the forward abutment, but while they were working on one abutment, the contractor was able to come in and work on the abutment that was opposite and use his equipment to come in from that day. So that's the reason here. This longitudinal joint right here had to be welded to be sealed through. And then what we did in the field, we talked about that. Rather than bring the crew out to metalize that one joint, we used a cold galvanized on this. I was also able to breathe a little easier because of the cold galvanizing on that, was because we are going to cover it up with a sheet type 3 rubber membrane.
Okay, great. Okay, so we're about 10 minutes after the hour, so I'm going to ask 2 more quick questions. The first one is how do you load rate this bridge?
Well, we're actually working with Carl Barth on that. Right now, the machine here, they're able to, in Ohio, we're actually able to do a visual inspection and go with an engineer's analysis. I've got his testing, and we're working with that, so we'll actually be able to publish that here in the future. We talked about it ahead of time, and I'm working with him to make that happen. Second of all, the machine has never failed the tub. It had over 1 million cycles on this. It had a concrete deck on it with an 8-inch overlay, 2 mats of resteel, and after 1 million cycles, the concrete deck completely disintegrated. So the decking disintegrated, but the tub itself never phased one bit. So I'm not afraid of that. So right now we're going with the Ohio DOT, and I'm using engineering judgment on it because we don't have, in the state of Ohio, we don't have a tabular form for the tub because it is that new. But we will have that, and we should be able to share that with you in the future.
That's great. Yeah, I was fortunate enough to see that test out in Iowa. It was pretty amazing. So, Doug, this is the last question, and it's for you. Is Ohio DOT considering the use of this bridge system on other projects?
I'll tell you what, looked like a piece of fruit with flies all over it today. We set this thing. It was awesome. There were people there with hard hats and safety vests on from all over the country. And yes, the Ohio DOT was there. The federal people were there. There were people from out of state that were there to look at it. And I really think this has been a successful project for ABC, a successful project for the Ohio DOT, and a really successful project for the Muskingum County Engineer's Office.
Well, it is a great project, Doug, and you mentioned it was one of the first, and I'd go as far as saying it is the first of its type in the country. So we congratulate you on that, and we're going to go ahead and pass this on to Mary Lou to close us out. Mary Lou?
Okay, thanks again to our speakers for your excellent presentations and Q&A session. Thanks also to Ben for moderating the Q&A session and to Kay for coordinating this presentation. Thanks to each of you for your participation in today's webinar. Please join us on October 19th for our next monthly webinar, which will feature the use of Texas pre-tension bent caps in ABC projects. This concludes today's webinar.
Oh, Mary Lou?